Welcome. This question to sum is probably one of the most popular questions on LeetCode. The question says, given an array of integers, nums, such as 2, 7, 11, 15, and an integer target, such as 9, return indices of the two numbers such that they add up to the target. For example, 0, 1 corresponding to 2, 7, so we return 0, 1. A brute force solution involving a double for loop, such as here, give us a time complexity of O(n) squared. The question is, can we find an algorithm that has less than O(n) squared time complexity? To arrive at a solution, first of all, we need to understand a very important concept known as hash table. The main illustration of a hash table is posted here. Please feel free to pause the video for a minute to review the information in detail. As you can see, when you want to find an element in a list by searching a list and using in, it's an iterative process and has a time complexity of O(n). Instead, you can also try to find the element in a dictionary by using a hash map, which has a time complexity of O(1). The reason of this is because the dictionary lookup process is memory location based, so it's a direct access to that memory location, and you don't need to go through all the other elements iteratively. That's why by using dictionary, we can reduce the O(n) squared, hopefully to O(n). With the concept of hash table in mind, we are now ready to come up with a solution. The basic idea is that we want to know whether the complement, which is target minus nums array element, exists somewhere in the nums array, and if it does, where it's located in the nums array. And for quick lookup, which is important for time complexity O(n), we want to have a dictionary where the key equals to the value in the original nums array, and the value equals to where it's located in the nums array or the index. Then, for example, when we process the first element, we can look up this hash map to see if the complement exists. So for 2, the complement is 7, and we see it exists. And then we also know where it's located in the original nums array, which is 1, index 1. Then we can return 0, 1 as the indices. With all the background knowledge introduced, we are now ready to write our code. But first of all, let's look at this code using brute force solution involving a double for loop. It's useful as a benchmark. Let's submit it. Charging. Take a while. And accept it. Let's see some details. So the runtime is 5,000 milliseconds. That's a lot of time. It's O(n) squared time complexity. Now we want to write our code with O(n) time complexity. So first of all, we define our hash map as a dictionary, and then we do a single for loop to iterate through the nums array. Okay, and for each element, we want to know two things. First, we want to know whether the complement already exists, right, in the hash map. Because if it does, we can simply return the original index and the complement's index, which is the hash map value as lookup by the complement as a key. And if it does not exist, it's fine. Then we will just add into the hash map with the value as a key and the location as an index. So value key is the value of nums, and the value is the location or the index in num. So this is important. And then we are now ready to run this code. Let's give it a shot. Charging accepted. Let's see. So it improved to less than 100 milliseconds. That's a big improvement from 5,000 milliseconds. Thank you so much for watching. See you next time.